So let us see one very interesting question. You should definitely first try it out before you are going to go through the discussion which I'm going to be presenting to you. Now here, this is a question where I'm going to give you my own modifications, the original modifications of the question which is presented to you here. See, whenever you guys are solving questions, suppose say this is a question that you are attempting, and you are coming across the solution which is going to be presented, then in this question what modifications can be done. If you modify, how the answers are going to be different. So if you start thinking on those lines, then you will be moving in the direction of solving some advanced level questions, and doing this is really essential for performing well in JEE advanced stage of the examination. Thinking in if you modify this question, what is going to be happening. But anyhow, let's first look at this question. So what you have here is a uniformly charged ring, half ring, radius is r. Now the point A is diametrically opposite to the topmost point of the ring. So here this distance is 2r. A is diametrically opposite to the topmost point, and at point A you are required to find the ratio of potential to the magnitude of electric field at that particular location. What would be this ratio? So this is a very interesting scenario where if you are going to observe, normally what you do is you find at the center of the ring electric field, potential and all. For the center point, if you take any element on the ring, all the elements are going to be equidistant. But this is a case where the distance of different points on that ring from point A, they are going to be having variable distances. But there is a very beautiful thing which is going to be happening in this. If you try to write the expression and see, eventually you will arrive at a case where, let's look at the solution. So have a look at this. So what I'm doing, from the center, I'm measuring angle theta and taking a small element on the ring. That small element on the ring has a charge dq, which is going to be lambda times r d theta. Now due to that dq, we are going to write the expression for potential at point A and the electric field at point A. So for doing that, I'm making some constructions. Look at the right diagram. So that element point that is making angle theta with the horizontal. So from C to A, if we join and C to the element on the ring, they are going to be equidistant, radius. So the triangle which is going to be constructed, see, x is the distance of the element from point A. The triangle which is going to be constructed is going to be isosceles triangle. Now angle ACP, that angle is going to be over there 90 plus theta. Now if that angle is 90 plus theta, then we can find angle CAP. So CAP angle would become, using some property, that will become 90 minus theta by 2. CPA angle will also be 90 minus theta whole divided by 2. Now at point A, the element will create electric field pointing away from the point P. So the horizontal components will get cancelled out because of symmetry. We are going to take the vertical component and we are going to sum it up. So that is what I have done over here. Integration of dE cos of 90 minus theta by 2. We are going to integrate it for theta varying from 0 to 180 degrees. Now this expression for dE, that is going to be k dq divided by r square, where r is x in this case. So k dq divided by x square. And for getting that x itself, we can make use of some geometry in the triangle. So if you drop a perpendicular from point C to the base AP, you have a right triangle over there whose hypotenuse is R. So half of x, that would be r cos of 90 minus theta by 2, or x will be 2r cos of 90 minus theta by 2. This expression, that would be x value. So if you substitute for x take this x and substitute and then put that d in that integral, you will get one integration like this. So numerator one cos of 90 minus theta by 2, and denominator when you are squaring x, you will get cos square. One cos term will get cancelled, and in the denominator one cos term would remain inside the integration. So then this becomes the expression for EA, and you have to integrate this for theta varying from 0 to 180 degrees. Where you are going to substitute dq will be equal to lambda times r d theta. In fact, this can be evaluated, but there is no need to evaluate this integration as such. Why we needn't evaluate this integration as such is what we require is only the ratio of potential at point A to electric field. This ratio is what is required. You also write the expression for VA. Now VA, the expression is k dq by x, and you are going to integrate that. Now note that here denominator is x power 1. So x power 1, you will get one cos 90 minus theta by 2 from that particular expression. Now look at the integrations that are there in electric field expression and VA expression. They are identical integrations with, of course, constants are different. Here you have 4r square, here you are having 2r. Those constants are different. So if you pull that constants out, you don't have to evaluate the integration at all. The integrations in this ratio, they are going to get cancelled out. Right? And you're going to get 2r as the answer for this particular question. Now here there is a very interesting thing for you to ponder upon. What if lambda is going to be some function of theta? Let's say a variable lambda. Then what happens to this ratio VA by EA? Will it still remain the same? You just pause the video and try to think about it. Will it be same or will it be different? Okay, now I'm going to tell you what is going to happen. See, if lambda is going to be a variable, if lambda is a variable, clearly the horizontal components of electric field need not cancel out. So in this scenario, because we have a uniformly charged ring, if you're going to take two opposite elements over there, their horizontal components cancelled out. That's why we are taking simply the vertical component and we are summing it up. But if you have variable lambda, then the horizontal components need not cancel out. Now the potential at point A to the electric field at point A, if you're going to find that ratio, that is not necessarily going to be the same. But even in the case of variable lambda, if you try to carefully think, if you are going to have variable lambda such that in one quarter lambda varies, in the other quarter ring also the lambda varies in an identical fashion such that you are going to have mirror images for charges. So whatever lambda value is there, here lambda 1, here lambda 2, lambda 2. If you are going to have this kind of a variation, then again the electric field horizontal components would cancel out and effectively you will have electric field only in the vertical direction. So if you have a variable lambda such that you are going to have mirror images of charges about the vertical line, then still this expression would be valid. That is VA by EA will be 2R. But otherwise this ratio will not be 2R. So like this, when you are solving questions, if you think, if suppose say you are going to modify this particular scenario, then what would happen? So thinking on these lines on different questions. Okay, what if the question is going to be changed like this? Then what would happen to the final answer? Now, when you think on these lines on different questions, your thought process will become better. You will be able to gain confidence in the particular chapter that you are practicing problems from. Eventually all these things will contribute for your better performance in the advanced stage of the examination. Okay, so that's it for now. All the best. I'll see you with yet another video. Take care. Bye.